So welcome to the to my Cujo and to the continuous delivery meetup. So thank you guys for joining. Today I just want to briefly discuss automated performance testing in your CI builds. The tagline is making sure your code meets your expectations before shipping your builds. Basically, what I want to talk about is a little bit like if you performance profile your application, so you know what kind of to expect from some of your routes of your like APIs or something like that. It's especially handy for APIs. And you kind of know, okay, so this route is kind of a heavy route, and we want to make sure that we do not exceed a certain threshold in latency or something like that, or in the amount of requests per second that this route can handle. Then that's something that you can test during your CI builds. And I will be doing a demonstration about that a little bit later. So who am I? My name is Stefan Hogenijk. I'm head of IT operations and infrastructure here at my Cujo. I have a Twitter that I barely use, and my GitHub account where I do publish things as open source, mostly Apache and MIT license. What is my Cujo? Just a brief introduction. I will try to keep it very short. My Cujo is a global video platform, video streaming platform for first and second division football clubs around the world. So we have Bhutan national team, we have Mongolia, also clubs in America, and actually I think almost every continent, South America, Europe. We do women's football as well, and some futsal. So over 60 countries and more than 4 continents. We do live and VOD. We also have mobile apps that people can stream, so it's mostly for like amateur-ish football clubs, but not truly amateur, but a little bit more professional than that. So why is performance testing your so that was the introduction from Cujo. If you have any more questions afterwards, please feel free. Does anybody here do performance testing already for their CI builds? You do. Can I ask you, how do you do it?
Well, we generally do simulations. So we do driving simulations, software for cars. And we want to be sure that the performance of the next build is sort of the same as the previous one. So we have recorded performance numbers of the software, and run the same test on the new version and see if it runs as fast or slower, and we load the different simulations.
Okay. But you run the entire app and you test it. Do you test endpoints, or is it like the complete binary that you perform?
We run the complete binary.
Yeah.
And because really the load testing is about the whole simulation, because it's the whole thing that needs to be tested. Because separate parts, don't tell much about your performance. It's the whole thing that you need to test.
Yes, exactly. So in this case, it will also be like I'm just loading some example routes, but in a real live scenario, you would need to basically profile every single endpoint. Basically, if you're doing an API, if you're doing a binary, of course, like a specialized simulation or load test would be more optimal. But this just caters towards like things like latency testing and requests per second and stuff like that. Anyone else? By any chance? Not yet? Okay. Basically, where do you start? You start by measuring your routes first. So you use a tool like we use Boom, but you can also use something like Apache Bench or Locust or something like that to load test and test for average response times, for requests per second, actually Apache Bench is a really good tool to test that initially. You just test your routes. You know how it will you expect it to behave. So I would suggest running this either in your CI directly, just to test it first, to check the output and to parse it to a file and just base your performance profiles on that. Or just put it on one machine and just run a test one by one. Make sure that you get the numbers on average, that you know what you can expect, and then enter that into your test. So let's say you change some endpoint and you kind of you made it a little bit slower, and you want to reject the build if it reaches a certain threshold, right? So that's also the topic of this discussion. But it allows you to deploy your code with just a little bit more confidence, because in addition to running your unit tests and your functional tests, you will also know how the performance approximately will be. And it is a fairly accurate way of testing your endpoints. Downside is it requires a little bit more configuration, and of course the runtime of your CI build will increase, mostly because every single load test takes time to run, obviously. You can also run it post CI, but if you do continuous delivery, then it's not really relevant, because then it's already deployed and it's already out there. So some people actually choose to do it post delivery, but only on test branches or test deployments, and they test it on a whole infrastructure rather than their CI build. This is just a CI build, but how we also plan to do it in the future is completely load test. Actually, we do it now, but we do it manually. We want to migrate to automatic load testing for development environments as well, to completely profile them, and before it hits production, make sure that it's already tested fully on real infrastructure. So that is kind of the plan. So we implemented.
Can I ask a question?
Of course.
For my understanding, your infrastructure is that you stream locally in regions, right, from a data center?
Yeah, correct.
Okay.
So we currently have 4 points of presence, 4 POPs.
Okay.
North America, South America, Europe, and Asia, in Singapore. We're planning to launch more POPs in the future. We're opening one in I think Melbourne, I think, or Sydney, and also Japan. So that's also, I think, in the pipeline for very soon. And Africa is also really up and coming. So we are trying to get, but it's kind of difficult in Africa a little bit. But we're trying to get one running in, I think, Johannesburg. Yeah. So South Africa is kind of the most stable region for deployments right now.
Number clarification. So you're speaking about performance testing of the application itself, or performance testing of the build process itself, like building the.
So not the build process, just the application, so the artifact basically.
Yeah. So you're testing the artifacts, but but that's post build. Like you build the artifact and then you test. Where do you deploy those artifacts? Like on the build environment?
So I will show that a little bit. So we just use containers, right? So we just we build the container, and then we run the container and we run tests against it, basically. This is what we do for our APIs and everything that is the most hard hit application. We want to know how they perform. Let's kind of continue, because I think this is already the live demo. I really do hope that the demo gods are friendly with me today, because this is the most exciting part for me always. So what I have is a simple Node.js application. So we do most of our applications here in Node.js, most of our APIs are in Node.js. We do have some things in what I already discussed earlier with some people here. Is we do have some applications in C, in Go, and also some Python, actually, and now also a little bit more Java for some of the data platform stuff. But this is just a simple Node.js API. It has a hello world route, just returns 200. It has a test route that I will be breaking, kind of, in order to show that the test will fail. And the last route is just you give it a number of milliseconds that this route would approximately take, and then it will just wait for that amount. So it's just fairly simple, very stupidly built API that will just do kind of the proof of concept. So we use, of course, Docker to build the artifact. and yeah, we don't use Jenkins, we use Circle CI, but the Jenkins file will look something similar. I mean, this is just very, very basic stuff. Can everybody read it, by the way? No. No? Is it too light in here, or is it just, is it better?
Closer.
Is it, yeah, you can move a little bit closer, I think, but is this okay? Okay, so we'll make this. So this is the most important thing. So in it kind of assumes that you can run Docker in your CI environment. So if you cannot, then yeah, so that will be a challenge. But I'm pretty sure that there's a way that you can make your application work, actually like function in your CI environment. But in Circle CI, what we do is we build a base image that has some tooling inside, like JQ and everything that we use here. I will also link to the test repository, so you can kind of try it out for yourself. But it will just check out the code, basically. It will set up a remote Docker host, a Docker daemon actually, to run the Docker commands against. It will build this repository, the MyCujo performance test demo. It will run it as a daemon and expose it on port 3000. The name is necessary because then we can bind the networking for the tests to that container, so it can reach the performance test can reach the application on localhost. We just do a sleep just to make sure that the container is up and running. I'm pretty sure that there are better ways. Maybe they also introduced like a minus wait or something, but I wasn't really sure. Didn't want to risk it. So here are the performance tests, right? So the performance tests are 4 performance tests right now. These test the slow routes, so they expect, for example, the one that waits for 200 milliseconds to respond within 250 milliseconds. The same for like the 300 route. It will expect an average response time of less than 350 milliseconds, etc. So the route that I'm going to break right now for you guys is the last one, the /new. So just explaining this command a little bit. So I built a load tester. This is by the way, my GitHub handle. Also, I will post. Actually, you can just check out this Docker container if you want to test it. It's just very simple. It's just an Alpine container with a load testing tool inside. That's it. That outputs JSON. The thing is that I kind of built a parser for AB that parses AB results from Apache Bench to JSON, but it was not working really well, so I decided to just use the one that outputted JSON. JQ is just the JSON parser, command line JSON parser that takes standard in as an argument and parses it. The -e means that it will exit upon non-true values. So if it's null or falsy, the condition in there, then it will just exit. So in this case, your build will just exit with exit code 1, and your build will fail if it doesn't meet the requirement. So in this case, I can rerun the build and show you that it will in fact build. Just rerun this. There we go. And afterwards, of course, I will break it. This is still readable, or do I need to kind of like? So this just spins up the environment. Does anybody here use Circle CI by any chance, or is it all Jenkins? You do?
I do.
Oh, okay, okay. Because of your Jenkins shirt, you kind of confused me.
I would say I try to use multiple systems to have an idea of how they work.
Oh, that's actually very good. Okay, so what are your thoughts about this tool, Circle CI?
Circle CI, especially for how to say somewhat standard kind of things, it's very easy to set up,
yeah.
Very comfortable to use. Especially if you also have some how to say private projects in GitHub, something like that, looks very nice. But if you need more complicated things or where you have and also different languages, then I would say Jenkins would be easier. But
Yeah, it's more extensible and everything, of course. Yeah, that makes a lot of sense. But this is, I mean, the tool that I'm showing is completely copy-pastable in Jenkins. That's fairly easy. So yeah, I did run the performance test. So it ran. It took like 22 seconds to complete all of the performance tests, and you can see here like 4 times it outputted true. So it will not fail. So this route performed as expected, and it performed within 200 milliseconds. So what we will do right now is we'll introduce this artificial response time. We'll make it 250 milliseconds. And this should, when I okay. There we go. So this is now, of course, triggering a new build. There we go. And let's pray it should fail. Because now, of course, the average response time of this route will no longer be less than 200 milliseconds. So my guess is it will fail. Otherwise, yeah, it didn't work. So so just a point of discussion. Do you guys think this will in any way like be useful, or what are your views on performance testing your builds in general, your artifacts?
I still don't follow the whole concept. In
Of
your
course.
build pipeline,
Yeah.
you build the Node.js application, and then you run a secondary.
If you want, I can just highlight a little bit more on that.
Yeah.
So, so what is your exact question?
Yeah, the question was, do you think this pipeline, you build the Node.js application,
Yeah.
and then you deploy inside a performance testing enabled Docker container, and then you run the application, and then you test with the tools inside the Docker container whether its response is 200 seconds.
Yeah. So yes, not really. It's just so it did fail, so it did work. So that's good. So it will just check out the code. It will build the Docker container. That's this this step. So just run a Docker build. Are you familiar with Docker in any way?
Yeah.
Okay, so yeah, it will just build the Docker container on this host. So CircleCI actually runs everything in Docker, so they have to assign a remote Docker daemon, basically. So you're connecting not to the instance where you run, because it's a container. You cannot run containers inside containers. That would be weird. But actually, technically, you can, as long as you run it somewhere on a VM. That's the remote Docker daemon that you get assigned by CircleCI. So how you do it on Jenkins is either you run Jenkins on virtual machines, then you can run anything that you want, or you use the same kind of mechanism. So you use also remote Docker daemons. This is handy if you run your Jenkins inside of Kubernetes or something, because then you can do it that way. And then the Docker run just makes the application available. So it just executes the binary. In your case, it would just be running the binary, and in this case, it's just running this small Node.js application. And these performance tests are all like separate executable. So we can also just export it as a binary and just execute the binary. It's the same thing. It's just easy for me to package everything in containers, so that it's very consistent. What I expect, how I expect it to behave on my laptop when I test it locally, and in my CI environment. It's like the exact same result. So yeah, it failed because obviously this route. So that, assuming we know that, so we still don't know from this through performance profiling. So because we don't know exactly where in the code the bottleneck lies. So you need to, besides doing this, because you don't want to make it too heavy, you either extend it here. You make it more, more deeper with like an APM, for example, to do application performance monitoring. I think it is. and you just use as an extension on your APM. So the APM will tell you exactly where your route, your application is behaving slowly. And this will just tell you the fact that it's slow and you cannot produce the build. So this will not produce the step deploy to Kubernetes, which the successful build did. So when you go to the successful build, the last step was deploy to Kubernetes. Now your image is not pushed, it won't do anything. So it'll just stop whatever it's doing. So this kind of polluted build, let's say, will never reach production because it just it's underperforming. So when you're doing heavy refactoring, it can and it will eventually happen that your application will not perform like you expect. Just make sure that you have sensible numbers there, that you expect it to always behave maybe 10 milliseconds above the average threshold, but never really that much higher. Because if the higher you put the threshold, the less accurate, the result will be. So yeah, now we'll just fixing the build is kind of redundant, I think, at this point, because yes, the build will succeed whenever I undo my change, basically, because it succeeded before that. Okay, are there any questions?
Yes, how did you determine the thresholds? The values that you say, okay, this test is passed or it's not?
So the question is, how do I determine if it's successful or unsuccessful?
Yeah, about the number of milliseconds that a test may take or call may take.
Okay, so first thing you do, so where you start first, is you test your application. So you run like a Apache Bench or Boom or any kind of performance profiling against your application. Preferably like on the same machine or somewhere where you control the latency, because network latency can also increase the average response time. You know what I mean? So it's kind of, you need to really know how your application itself, excluding, for example, the networking and everything. It's handy to do it both. So that's why we're also moving to a automated testing scenario where we actually have a test that tests the whole infrastructure rather than just only the application. But you just run. You can use the same tool mentioned here to test for average response time. So what you actually do is actually how I did it is very simple. I'll just zoom in to make it a little bit easier. This is the app. It's running right now, and there we go. And you can see on the right side that it executed 10 requests, right? Mm-hmm. They do not perform like expected. But so if I make it less than, for example, 300 milliseconds, and then it does respond within the.
Yes,
but
okay. I think I have to rephrase my question a bit.
Okay. I think.
Why do you think 300 milliseconds is good, and 200 and 400 is not good? How do you come up with these numbers?
Okay, so you just test your average response times or your maximum response times. I think a maximum response time is also a good indication of where you kind of want the ballpark figure to be. So it's really just like looking at these these performance numbers. You have here the request per second that this route was able to take. This also depends a little bit on your own networking stack. The total time that the 10 requests took, the minimum and the maximum. So the maximum is always, for me at least, a good indicator of saying, okay, it should perform below this number, or at or below this number. Give or take 10 or 20 milliseconds maybe if you have a very high, demanding route. But so what I did is just I used those metrics. I ran those tests a couple of times. I made sure that they're reliable numbers, and that's what I use. So mostly the maximum response time.
Yeah, and how much, the last question, sorry.
No, sure, ask as many questions as you want.
What would be the actual number of requests towards that endpoint? So you are saying, yeah, 200 milliseconds is a good response.
Yeah.
What if the actual number of requests is 1,000 concurrent users? So then the millisecond metric would be even higher. How do you define the number 200 millisecond based on which parameters, like the number of requests, concurrent requests, or you're using some historical data about how well your
so that's what I told you, like APM, application performance monitoring can come into place, because then you also know how it will behave in real life. So this is just really just the raw routes itself. There are many factors when it comes to like performance monitoring, because there's database performance when you're using external assets, or Redis, or Memcache if you're doing caching or whatever. There are a lot of like external, this actually responsible for 90% of the slowness of your application is external factors. It's like databases, whatever, you know, like MongoDB or MySQL or Postgres. Application performance monitoring, like running an APM, you can do this, I think, now with Elasticsearch as well. Is kind of like essential, you know, for getting true, accurate numbers. And it might indeed, when you're running everything in a predictable environment, so your CI is a predictable environment. This is an expected environment, let's say, because you spawn your database containers there, you have your caching there, you have all the things there that would be there in production. So application-wise, it will be accurate. It will be fairly accurate. I've not seen a single build fail because of sheer inaccuracy. It is accurate. But load testing your actual infrastructure is always a good idea. We even load test our production environments to make sure that, for example, when there's a very high concurrent match, like for example we had one time, was it Thailand versus India? I don't remember.
No, yeah, the women game.
No,
Yesterday.
No, not the one from yesterday. That was a Champions League match, actually. That yesterday was
no, there was a game today, Thailand. Thailand, Myanmar.
Thailand, Myanmar. So there are some matches that are so intensely popular that we get like a lot of people, you know, like tens of thousands of people simultaneously watching a stream. We actually get like a lot of concurrent connections. Then, like most sites serve their content, you know, and can cache a lot of things. For us, it's live streaming. It's a lot of dynamic content, a lot of WebSockets, a lot of data going back and forth, which makes it, you know, kind of heavy. And we want to make sure that we can handle it. So we do also external, like actual infrastructure testing.
So isn't that making what you said right now? Isn't that making this performance testing within this controlled built environment redundant or unnecessary?
So,
because it's for me it looks like a sanity check. So whether the developer didn't mess up. So let's test whether this container is going to handle 100 milliseconds.
No, so
then the build passed.
Yeah, so just look at it as kind of like a unit test, right? So just look at it as maybe a functional test.
Not a true performance.
It's not a true. It's kind of, it's just a performance test of that specific piece of code. So it's like it is like a unit test. It's basically like a kind of functional test. It's like kind of, what do we expect? We expect this route. It's just an extension on top of your unit and functional testing, and that is actually it. It won't load test. It's not a true load testing.
Yeah, but yeah, maybe we can do. I mean, from my perspective, a true performance test would be after you deploy to the Kubernetes cluster in a namespace, which is like a staging or pre-production environment, and then you do performance testing. And then you do the.
That is exactly what we're now also setting up. And also, so you also deploy on the test environments. You also deploy all the load testing stuff, and you know exactly. I don't know, with 10 pods or with 3 nodes, and with this configuration, it can take 1,000 users, or it can take 20 users. It will respond within this amount.
In order to be true performance test, you need to test on one pod. One pod, nothing else. No autoscaling, no groups. So that's a true performance test when the actual application is deployed on the infrastructure, in this case Kubernetes. And that's performance test. That's why then you need to put this performance test through the Kubernetes cluster and check how much one instance of your container, Docker container, would handle, and whether then it will reach these metrics like 200 milliseconds, 400. If not, then
yes, I agree with it. But in this case, like, you can do all that here. But in terms of like, if you deploy the application into a pod, then you can also take into account, like, for example, your CPU usage of a route or the total thing. So that's indeed, but it's a separate test.
Yeah.
I don't consider this a replacement of
load
an actual load or performance test. It's just
load testing is completely different. So you
Yes.
can say, yeah, this is our pre-production environment,
Yeah.
staging. This is where we hit the load. We expect million viewers, and then.
yeah, but and indeed, but I see that as a completely separate paradigm, and I don't
You
think
don't want to wait for your build to do the complete load test.
no, that's exactly
After
it.
you release,
Yeah.
load some, push and
Yeah.
deploy. That's it.
You would probably do those in parallel, continuously,
Yeah.
on how to say branches that are making it to production. But this, again, as you said before, like a sanity check, especially when you're refactoring, like, okay, I think this changes nothing. Suddenly performance is doubled, how to say, the latency is doubled. Oh shit. Right, and doing any performance testing on that afterwards is useless, because obviously something's so big wrong that probably in the last few changes you made, something is there, and you'll have to, okay, you can very quickly see, okay, I probably maybe duplicated some code accidentally, call function twice, something like that.
Yeah.
For that, it's definitely useful, and I think maybe one of the things we often forget when we do CI is to
Yeah.
have, at least, at the very least, some sanity check, okay, this should not perform, this should not take any longer than, for example, 200 milliseconds, and then we do some refactoring, take 600. Oops.
Yeah. Even another question arises. So, how many requests you are doing? Can you show us the boom configuration or AB? What's inside this
Sorry?
performance container?
Oh no,
How many
it's
requests?
only the tool. So everything I'm doing is just from the command line, right? So
So this
Yeah,
is
from the command
standard.
line, but
what do you mean?
can you show the Docker file for the actual performance container?
Yeah.
The one who's to run. the
But
test?
yeah, sure, I can, of course. This is it. But yeah, so this is really good. So this is just.
What's in the run SH? Or what in the?
Oh no, that's commented out actually. I only execute the and it's just the same kind of tool as AB. It's like kind of AB, but then with JSON format, and it uses a slightly different.
Okay, boom, the successor of AB. But how many concurrent requests? Even if you use AB, you put okay 10.
Yeah, but it has the same.
10 concurrent.
Yeah, it has the
10,
same
right?
option. So you can do 10 concurrent connections, for example. You can,
Yeah.
if you do -C and
That's what he configured.
Yeah.
Yeah, exactly.
so you can actually also, for example, do 100 requests and then
okay, so
10 at
yeah.
the same time.
100 requests, concurrent 10. Okay, that
Yeah.
makes sense. Yeah.
Okay.
But that's for a limited amount of requests. So those values are still not valid. Like 200 milliseconds for 100 users per request and 10 concurrent. So that's still not a valid performance test for me.
It's just a sample. Just an example.
Yeah, but how do you, in production, how do you define these numbers?
Based on actual request logs.
Yeah.
Yeah, you check the
Like a
request
dynamic-
logs for last month,
Yeah.
or the busiest month, the busiest
Well,
day of the
that's
year.
the answer we wanted to have. So historically, you get a request for each.
But this is like all like data from Prometheus, from Elasticsearch that you export. You can just take a look at it. Yeah, that's why initial performance testing is a really good idea, and you should have solid numbers. You cannot do it otherwise. It doesn't make any sense.
What we do with us is, so for the WorldCon webshop,
Yeah.
daily we do there are almost daily releases. Every night there's a load test with us, a normal day, and then every weekend we have the season. So
It's a really good job. It's the way how you can predict your load, and track everything, and make sure it's not going to get a faulty build.
yeah,
Okay.
Thank you very much.
as long as the build is quick and
Yeah.
Yeah, I was thinking of like
Yeah.
test-driven development. So you will also put in a test. Say I want this endpoint to respond on average below this many milliseconds. And
Yeah, but that's that's cool if you're building a new route. Let's say you're
Oh.
building a new route,
Mhm.
then you can do like a TDD approach. Like, okay, I built this new route. I expect it to behave just like my other routes. Just
Mhm.
like this other route, you take a reference
Similar,
route.
yeah.
You say like 50 milliseconds. That's a good number. If it performs worse, then you need to
Mhm.
seriously think about your code. Many developers don't want to admit that it's their code that breaks the platform,
Mhm.
but many times it is. And then ops engineers are like, what? No, but the hardware is good, right? It's awesome. It's like we have 100 servers. They should be able to handle your request.
Mhm.
Your application is just slow. And
Yeah.
this will prove that statement.
It's trying to think like a step further when you start to design your application that you keep timing in mind.
Of course. And that's also kind of the paradigm. So indeed, that's a good point.
Especially with microservice that call each
Yeah.
other. Yeah.
Yes,
Of
exactly.
course, you should have metrics on every input
And timeouts.
and timeouts.
And timeout, yes. Exactly.
Yeah.
So that was it for me. If there are no more questions, then I would like to give the floor to Joost. And thank you for your time and attention.